So impairment, we have three types: attenuations, distortion, and noise. Okay. Attenuations is the loss of energy, loss of power. If you transmit the data, that without power we cannot transmit it, whether the electrical signal or the radio wave or light wave, we need the power to transmit. Okay, that original signals is attenuated, that it lost the power, then we have to amplify the signals. Then this attenuated signals is measured in terms of the decibel. Okay, decibel. Then the next one is distortions. What is the distortions? It means change in the form of the shape of the signals. So it can change the signal formations. Okay, signal formations, like if it is a digital signals or maybe analog signals, then it's distorted the signals. Okay, it's distort the signal. This generally seen in the composite signals made up with different frequency. Each frequency component has its own propagation speed traveling through a medium, and that's why it's delay in arriving at the final destinations. Every components arrive at destination different times, which leads to distort. Therefore they have different phase of receiver, each from what they had a sender and. Phase means, if we say this composite signals, okay, composite signals, if we say this composite signals, this is analog signals. Okay, analog signals, then each and every analog signals having a phase. Okay, let me show you in internet. Phase of analog signal. So in each and every analog signals, okay, in this analog signals, that is start from this 0 to 90 degree and 180 degree, and here 180 degree, 270 and 360. That is complete the one cycle in the analog format, analog signals. Let me show you one more. Writing. Sorry. Okay. Okay, in this we have a phase. Okay, we have a phase. If we draw that circle, okay, this is circle, then here we have a 0 degree, this is 90 degree, and this is 180 degree, 180, then this is 270 degree, and if it's circle, this is 360. Okay, 360 degree, 360 degree. Then here the waves start from this. Okay, the waves start from this point. It starts from this point and it goes up to this 190 degree. Up to this 190 degree. Okay, then in the analog signals, we say that this direction is the time. Okay, this is the direction. This direction is the time, and this side is the amplitude. Say this amplitude. Then this is the time. Then here, if we complete the signal in some portion of time, okay, some portion of time. This is called the uh, frequency. Okay, we say the frequency. If we complete this one in 1 second, 1 second, if we complete in 1 second, one cycle, then this is called 1 hertz in analog signal. But if we complete these signals in 2 cycle in a seconds, then this is called the 2 hertz. Okay, this is the unit measurement of the frequency. So this is the phase. Okay, I hope that you clear that how come this phase. Okay, then from here 0 to 90 degree, then it goes to this 180 degree again. From 180 degree, then it goes to the 270 degree, and from this 270 degree it goes back to the original positions. Then this is 360 degree. From this 360 it starts the cycle again to 190 and the second cycle again. So each and every sequence we have a cycle. So if 200 cycle per second in 1 second, if it's complete 200 cycle, means 0 to 360 degree 200 times, then the frequency unit is the 200 hertz. Okay, or if it is the millionth of cycle, then 1 megahertz, something like this. Okay, I think that's clear, this one. So here it's phase. Okay, then therefore they have a different phase at the receivers. So there are the multiple of signals sent to a medium, then it's having a different phases. Okay, different phases. Here the cycle is different, here the cycle is different, here the cycle is different. In each and every cycle, in every time period, given time period, the cycle is different. Okay, so at the receiving end, that component signal received is distorted. Okay, it cannot receive the original signal. So this is the one of the transition impairment. Okay, this is called distortion. It's changed the formations, its form. Okay, that it's changing the formations. Noise. The random of unwanted signals that's mixed up with the original signals is called noise. Okay, here also I'm talking with a microphone, but beside me there's lots of noise sounds generated from the server, computers, and outside civil workers they are doing. Then it's mixed up with my original voice. Okay, this is called noise. Noise means unwanted signals. Okay, unwanted signals that mix up with the original signals. So there are several types of noise, such as induction noise, crosstalk, thermal noise, and impulse noise, which may corrupt the signals. Okay, which can cause the error in the original signals. Induced noise comes from the source, such as motors and appliances. So that inductance, that induced noise, okay, like motors, appliances, or different types of equipment, fan, okay, induction motors or something like that. This device act as sending antenna and transmission media, act as receiving antenna. Thermal noise is the movement of electrons inward, which create extra signals. So there's lots of movements in the electrons in the conductors, so it's create extra signals. Crosstalk noise when one way affect another way. So if you cabling your network with the domestic line, we can say this electrical line, then there's lots of electrons flow in this domestic electrical line. that create a crosstalk in our internet network. So you have to know that you cannot lay the cable network cables, let's say network cable with the domestic line, electrical line. Okay, it will create a crosstalk with the original signal. Okay, impulse noise signals which have which high energy that comes from the lightnings or power line. Wait a minute. Hello.
Oh, hello. Anh tem một đứa đi gần chưa mà sợ tiền gì hết kinh hết vui gì đó mà.
Ngoro karon kalau in la silong class kala lok o.
Ole. Oh.
Impulse noise is signals which highly that comes from the lightning or power lines. Okay? So high energy come from this impulse noise. Okay, these are the three things comes under this transmission impairment. Number one is the attenuation. Number two is the distortions, and the third one is the noise. Okay. Performance of network. How we are classify the performance of the network. Performance of network pertain to the measures of the quality of the network perceived by the users. There are different ways to measure the performance of the network depending upon the nature and design of the network. These characteristics that measures the performance of the network are the bandwidth, throughput, latency, okay, bandwidth, delay product, and jitter. So nowadays the internet services is the must, we can say, this mandatory, you can say. For the gamer also is mandatory. Without the internet connections we cannot join the community. Those who are working in the freelancer, coding or the data entry or any other things, then internet is very important. And those who study, graduate or the postgraduate or any short-term course or anything, nowadays we cannot have contact class. Just now also we are doing the online class, so we cannot have the offline contact class. What is the important point to get the educations using this during the time of this pandemic? This is called internet. Okay, first thing first is the internet during this pandemic and online class. Without internet you cannot avail the online facilities, online class, online freelancers. Okay, so our interconnectivity and then the services measures the performance in terms of this point: bandwidth, throughput, latency, and bandwidth, delay product, and jittering. Let's see here the first one. What is bandwidth? One of the essential conditions of the website performance is the amount of the bandwidth allocated to the network. Bandwidth determines how speedy the website server is able to upload The request informations where there are different factors to consider with respect of site performance bandwidth is every now and again the restricting element. Okay, restricting elements. A bandwidth is characterized on the measure of the information that can be transmitted in the fixed measure of time. The can be used in the two different contexts with two distinctive estimating value. In case of the digital devices, the bandwidth is measured in bit per second, bps, or the bytes per second. So this is very important, bit per second and byte per second. In a per second, in a second, okay, in each and every second it transmit bit or byte. Which one is the fastest one, bit or byte? Bit or byte. That we have to know that if it is megabit per second or megabytes per second, the speed is different. Okay, byte is faster than bit. Okay, if you